Hi guys, I am Logishan. I am going to show how to do basic analysis in COMSOL software. First of all, we need to open the COMSOL software. Therefore, go to Start button, type COMSOL and select the COMSOL icon. And wait until come. Here I am going to show you how to draw the basic shapes and how to analyze the electric field pattern, voltage pattern of the design. When you click the icon, the menu will come like this. Here we need to select the model wizard. In model wizard you can see there are 3D, 2D asymmetric, 2D, 1D asymmetric, 1D and OD models are there. Here I am going to show you how to do the simulations in 2D. Therefore, I am clicking 2D. When you click 2D, you will get the select physics module. Here I am going to do the analysis of electric field and voltage. Therefore, I am going to go to AC DC physics and select electric currents and click add button. When you click add button, the electric currents will come here. After that, you want to press the study. When you press the study, you want to select the study button, study option. Here there are frequency domain and small signal analysis frequency domain and stationary and time dependent studies are there. Here I am going to do frequency domain analysis. Therefore, I am select frequency domain and click done. When you do all the things, finally this COMSOL menu will appear. Here we need to set the length unit. This is the important thing here. Therefore, we can select all the lengths here. You can centimeters, millimeters, micrometers, kilometer, yard, feet, all the things, all the units are here. But here I am going to work on micrometer. Therefore, I am going to select the micrometer. Here first I will show you how to draw the basic shapes. For that, we want to go to geometry and right click and select the basic shapes what you want: circle, ellipse, rectangle, square, or the point or polygons, whatever you want. I am going to show you the circle. When you click the circle, you want to set the radius and the axis of the origin. Here I am going to set 10 micrometers radius and 0 0 x and y axis coordinate and build all objects and you will get the circle. If you want to draw a square, go to and right click and rectangular, and I am going to draw a square in 10 width and 10 height at center of origin and build selected, and you will get a square like this. When you want to delete something, you want to go and right click on the circle and press delete, and yes, and the circle will go. Like that, you want to delete the rectangle, go and select rectangle and click delete and it will go. For drawing by hand, not by giving the coordinates and the values, you can go to geometry here and select whatever shapes you want and draw by mouse point. If you want circle, you can draw like this. Again, if you want to delete that, you can go and right click it and press delete, yes, and you want to right click it, delete, click rectangular and press delete and it will go. Today I am going to show an electric field pattern on an electrode, micro electrode. Therefore, I have an design which was already drawn in AutoCAD. I am going to import that design here and do the further analysis. For that, go to import. When you click the import, you will get a menu like this and you want to browse the file, and I have a file here and I am going to open it and click import. When you click import, your design will import to this menu. It will take some time because my design is little bit tricky. Now the design is imported and it is in a magnification scale, therefore I am going to do the zoom out and I got the final design. This is my final design. This is the electrode. I am going to analyze the field pattern and the voltage pattern. Before that, my electrode is going to print on the glass surface, therefore I want a glass surface, therefore I am going to draw a glass surface here by manually by mouse. Okay. Now I draw the glass surface and the electrodes are here, and the electrode is made of copper. After drawing your design, we want to select the materials. To select the materials, on your right hand side corner you have add material, and in add material you have several options. You can select whatever material you want. I am going to select copper and click add to component, and it will take some time and it will come under the left hand material menu. Like that, I want silica glass for the glass surface. Therefore I am going to click silica glass and add to component, and silica glass came here. When you click copper, all things collected as copper, but I want the electrode only as the copper, therefore I am going to get rid of the glass. Now all electrode is selected as copper, and I am going to select the glass surface by silica glass. Here you can change the parameters manually also by clicking here and typing it, but I am not going to change the parameters because the parameters which is already default here is enough for me. After selecting the materials, the next thing is we want to set the boundary condition for this electrode. For that, I am going to right click and select electric potential, and it will come as electric potential 1, and I want plus and minus, therefore I am going to take electric potential again. Sorry, it is electric shielding, and I want the electric potential. Now I have electric potential 1 and electric potential 2. I want to set the values here, electric potential 2 and electric potential 1. By only giving the values we can do that, but what I am going to do is I am going to add a parameter and give the parameter name here as a voltage. Therefore, to set the parameter, go to definition and click parameters and type the name voltage, and I am going to give 10 voltage and it will select it. After that, in electric potential 1 I am going to give voltage name here, and in electric potential 2 I am going to give voltage of minus voltage. After that, I want to show which electrode area I am going to give the plus voltage. For that, I want to select. For selecting, we have a selecting tool here. It is easy to select all the things. I am going to apply plus voltage to this electrode and the electrode at the center, and electrode at the bottom. Oh no, the electric at the bottom, and I am going to select this even as plus voltage. Plus voltage means it is plus 10 voltage because we set voltage is equal to 10 at the parameters. Like that. then I want to apply the minus voltage, that means minus 10 to the electrode which is in between the plus electrodes. Therefore, again I am going to select box and selecting the electrode where I want to give the minus voltage. Again go to select box and drawing the area of electrode where I want to give the minus voltage, and I am clicking this seal. Okay. Now I successfully set the boundary conditions. After that we want to mesh this electrode design. To mesh this electrode design, we need to click the mesh on the left hand side. When you click that, this menu will appear. Here you can see several types of meshes, element sizes, that means extremely fine, extra fine, finer, fine, normal, there are lots of things. I am going to select normal, and if I click mesh build tool at the top, it will start to mesh. If I want to do the mesh by selecting the values what I want, I go to fish control mesh and select as user control mesh. When I select as user control mesh, you will have some menu appear here. Then I can go to size and I can set the element size what I want, and now it is 38.2 micrometer and it is set as 0.171 micrometers is default. If you want to change that, you can, by clicking this you can change that, but I am not going to change that. Therefore, I am going to use this and click build tool. When you click build tool, it will start to mesh, but it will take some time because the minimum element size is 0.171. It will take some time. Therefore, I am going to minimize this window, and I already have a meshed one. I am going to take that. When it completely meshed, the diagram will look like this. Here you can see the meshes at the glass surface is little bit bigger and the meshes over the electrode is little bit low, because we set the minimum element size as 0.171 something and the bigger one is 38 micrometer, that therefore it is coming like that. After meshing, I am going to compute that. For that, I am going to select the frequency domain and we need to set the frequency. Here you can set the frequencies whatever you want. I am going to set as 100 kilohertz, and after setting that I will come to study and press compute button. When I press compute button, it will take some time to compute because there are lots of meshes. It want to mesh compute and get the values for all the meshes, then only we can get the values throughout the image. We need to wait for some time until it's simulate and give the pattern. Now it's simulated and it's give the pattern. This pattern is the voltage pattern because when we click the compute button, it's defaultly given as voltage, therefore it's giving the voltage pattern. Then if you want to analyze the results for different patterns, we want to come to the electric potential under the results and click the surface, and you can see the expression given is voltage. I am going to analyze the electric field pattern of this electrode. Therefore, I am going to this arrow key and electric currents and electric, and here electric field normalized electric field is given by this unit. I am going to click this and it will appear here. When it appear here, I am going to click the plot button and it will give the electric field pattern throughout the electrode. But here I cannot see clearly where the electric field is high and where the electric field is low, because it's almost all I can see is yellow color, but I want to see how the electric field is distributed clearly. Therefore, I am going to change the color by manually by clicking the manual, and I am going to change the maximum by dragging this. While I dragging this, you can see the difference on the electrode. Yeah, I am going to leave like this. Now you can see clearly see the electric field pattern how is distributed over the electrode, and but you don't know what's the value at exact points. We can estimate it's nearly 0.8201 is in the high field region, and and I'm going to we can just see how the distribution is, but we don't know the value, exact value. Therefore, we can draw a cut line and we can get all the values from this plot. For that, I am going to data sets, right click and cut line 2D. In cut line 2D, I want to give the xy coordinates of the line. Here I am going to give x axis from 0 to 350 and y is 160 and 160, and I am going to plot it. When I plot it, you can see the cut line appear here. Now I am going to get all the values throughout the cut line. For getting that value, I am going to right click this results and go to 1D plot, and in 1D plot I am going to right click again and line graph, and this menu will appear. From this menu we need to select, we need the value from the cut line 2D1. Therefore, I am going to select that, and other thing is we need to select what expression we need. Here I want the electric field pattern, therefore again I am going to select that electric field pattern as earlier and plot it, and it will give the electric field pattern of the cut line. And if I want to change the expression as voltage, I can easily type V here and plot it. Here this is the voltage pattern of the electrode. Now here also I cannot see the exact value, I want the exact points over this graph. Therefore, I can export this at plot data to export. By clicking this, I can export this graph to the Excel file. Otherwise we can click the export and we can export the data, plot, table, whatever we want to the Excel file. Then we can analyze the data very easily. Now I am going to show how we are going to uh, do the animation, export an animation. To make an animation, we want a parametric sweep, then only we can get the animation. Here we set the parameters earlier, voltage as 10, and I am going to do a parametric sweep. To do a parametric sweep, I am going to right click the study and click parametric sweep. In parametric sweep, I am going to select add, and when I select add button, I have only one parameter is voltage, it will appear. If you have many parameters, all will appear here and you can select, and I am going to change the voltage, therefore I am selecting voltage. After clicking this, I am going to set this start point from 10 voltage to minus 10 voltage by step size is 1, and I am going to add that. After adding this, I am going to click compute, and it will take a bit time to compute because it will compute all over the plane. Okay, what's the problem? its occur is we'll see, voltage is and compute the following feature has encountered a problem, parameter list gives empty sweep. Okay, add, and I'm going to do it from -10 to +10 is replace. We'll see what's happening. And it will take some time to compute this parametric sweep, because we the parametric will sweep will calculate all the electric field value and electric field pattern throughout 10 voltage to -10 voltage. Therefore it will take little bit time, we need to wait for that. It's loading because it's calculating for all voltages. You can see here it's running at the bottom, the green color. When it finish, the electric field pattern will appear here. After that we can do the animation. Here we got the electric field pattern. Now the parametric sweep was finished. After that we are going to do the animation export. Therefore go to export, right click and click animation. Here the animation menu will come like this. You want to select a name. I am going to name as DBL and click save, and we can set the frame rate, and we can set the all parameter here whatever we want, and I'm going to leave it as it's set, and I'm going to click the export button. When I click export, again it will load some time to export the image as a GIF file. Wait for some time. Now you can see it start to export, because you can see the field pattern on the screen. It's reducing, because in the sinusoidal voltage when it's come to -10 to 10, it -10 to 0 and 0 to 10 and 10 to 0, it will go like that in a sinusoidal voltage. Therefore now it's came to 0 and it's going to increase again. You can clearly see the field pattern with the voltage by increasing in step size 1. After it's exported, I saved it as DBL1 DBL, and I am going to click that. Here you can see clearly how the electric field pattern is varying as an animation. Like that we can do the animation for by varying other parameters also. Then after that we need to save this file. As usual, saving in other programs, click file and click save, and I am going to DBL, name it as DBL 2, and I am going to save it. Now the model is saving. Here we learn how to draw basic shapes and how to delete the basic shapes. After that, how to set the materials to that design, and how to set the boundary conditions for the design and the electrode, and how to mesh and how to mesh different sizes, how to set the different sizes in mesh, and how to set the frequency in the frequency domain, and how to compute that. After that, we can studied again how to do the parametric sweep and how to export an animation like that. And also we studied how to draw a cut line and how to change the unit of the cut line and how to analyze the field pattern and how to export that cut line data to the Excel file. Like that, we studied the basic stuff of COMSOL. That's it. Thank you for watching this video, and I am thanking the DBL class to giving an opportunity to share my knowledge with other students. Thank you so much.